So let's say that we have the particle that is forced to live between x equals 0 and x equals L, and that it is in a state given by the following wave function. Let's just maybe for the time being ignore the exact value of A. We can easily figure out what that is, but that's not our focus now. We'll make this a superposition clearly of n equals 1 and n equals 2. So we have 2 pi x over L e to the minus I e2 t over h bar. Maybe we can say that A is some positive real number. Doesn't really matter. Let's look at the probability density. In other words, probability density P, which is psi of x and t modulus squared. Right, we integrate that object over some range in distance to find the probability of measuring the particle to be in that range. So the probability density is psi star psi. So we have to evaluate those two things. So what does that look like? Psi star is, given that A is real, we just have A sine of pi x over L e to the I e1 t over h bar plus A, starting to write the exponential part already, sine of 2 pi x over L e to the I e2 t over h bar times A sine pi x over L e to the minus I e1 t over h bar, right? This is psi. This whole thing is psi star. And that gives us A squared sine squared of pi x over L, right? This times this. Cross terms, we also have an A squared there. Sine of pi x over L sine of 2 pi x over L e to the I e2 minus e1 t over h bar. So this is this term, this times this. And then we have the other cross term, which gives us, let's write it here, plus e to the minus I, same difference, e2 minus e1 t over h bar, e to the minus IE2 and e to the IE1, so it's this times that, plus this times that, which gives us a squared sine squared of 2 pi x over L. So notice that these two terms are the same up to this factor. So we can pull out the a squared sine pi x over L sine 2 pi x over L and multiply that by an object that in parentheses has this plus that. But notice that this is like e to the I x, where x is this whole thing. Let's, I don't want to use the variable x, but let's just use a different variable. E to the I y, where y represents this whole term here without the I, and this represents e to the minus I y, so this is plus e to the minus I y. But that is cosine of y plus I sine of y, which is this, plus this is the cosine of y, because the cosine is an even function, minus I sine of y. This whole thing is this, and this is, we obviously are canceling the sine terms. We get rid of the imaginary part, so we just get twice the cosine of y. And so what we ultimately get is twice the cosine of e2 minus e1t over h bar. And so overall, the probability density looks like we could pull out the a squared, but I'm just carrying it along. We square the first part with no time dependence. We have an additional time-independent term, 2 pi x over L. And then we have the time-dependent part, which involves the energy difference. Excuse me. So we have 2a squared sine of pi x over L sine of 2 pi x over L times the cosine of the difference in energy, E2 minus E1t over h bar. And so this term will make the probability density change with time. And so one thing that to emerge from this is that if you want dynamics, if you want time dependence, you need to have different values of energy. There is no time dependence if you only have one value of energy.